Okay, here we are with the last two examples here. Example 6 wants us to find an equation for a tangent line, so we know whenever we see that we need a slope and a point. So we're given a parametric, we have an x equation and a y equation, and we're going to be given a time value. So time is 1. So we need slope first, or a point, which one you want to do first, but I'm going to go ahead and do slope. So we know we are doing first derivative of our parametric. So derivative of y is -1 over t squared divided by derivative of x, which is just 1. So there's our slope equation. So now we can go ahead and plug our t value in. So if we plug our t into our slope equation, we end up with our slope equals -1. And now we find a point by taking our time and plugging it into both equations, find an x and a y. So if we plug in 1 for x, we get 0. And then if we go ahead and plug in 1 here, we end up with 2. So our coordinate is 0, 2. That's our point and a slope. Point slope formula. Y minus y equals slope times x minus x. There we go. So we can clean this up if you want. You could leave it like that. So we know we get -x plus 2 if we wanted it in slope-intercept form. But again, either one's good. All right, last topic here, arc length of a parametric curve. So we've dealt with arc length before. And if we look at this equation for arc length, it should look pretty familiar. So we know we are dealing with Pythagorean theorem. That's how we end up with these equations for arc length. So we're taking the integral from some time to another time of our square root of our two derivative functions squared, and then we're going to add them together. All right, so it's pretty straightforward. So using parametric equation from example 6, find the arc length on the interval 1 to 3. So let's go ahead and do that. So from 1 to 3, and then we're doing our square root of our x, our dx equation. So derivative of x, if we look back up here, was 1, plus our derivative of y. I'm just going to rewrite. I'm going to write it like this. Okay. And then from here, all we have to do is plug this into the calculator, which I have not done that yet. So let's go ahead and do that. So you probably should try it yourself. Make sure you get the same thing that I get. Okay, so from 1 to 3, and you can be in any mode for this. You could be in rectangular, you could be in parametric, you're going to get the same thing. Obviously, if you're in rectangular, you're just going to be using x's for your variables when you type this out. So you should end up with a 2.147. That's it. So if you have any questions on this section, parametrics, let me know and we can get together and talk about it.